All right, so today we have Brian Raymond, founder and CEO of Unstructured. And I'm going to read off of the website here. Unstructured makes enterprise data AI friendly with open source building blocks that connect the world's messiest data to the world's most powerful LLMs. But I actually like their tagline even more, which is ETL for LLMs. In full disclosure, I probably will become an advisor to the company Unstructured, although we will make sure this podcast is useful and not a product pitch. And another aside before we start, Brian will be hosting a panel at the upcoming AI conference. And you can find out more about the program, and I'm the program chair. We have an outstanding lineup for you at aiconference.com. This is an in-person conference in San Francisco from September 26 to 27. So with that, Brian, welcome to the Data Exchange podcast.
Thanks for having me. It's a pleasure to be here.
So we're in the age of LLMs. There are so many startups focus on aspects of building custom LLMs, although I think there is a bit of a over investment, over emphasis on things like fine tuning and I guess hallucination mitigation and various aspects of training. So I was quite happy to see that you folks at Unstructured focused on data integration and ETL. So why in the world did you focus on this aspect, which, by the way, I think is so important and so fundamental? I'm surprised actually not many people focus on this. So what is the origin story of Unstructured?
The origin story of this is a problem in search of technology. And so, a previous company that I was at, a wonderful company, Primer AI, I joined them early on, and it was right as transformer-based models started to be adopted. And at Primer, we're doing some great work fine-tuning those models, orchestrating them into pipelines, creating knowledge graphs, building apps on top of them. We had some phenomenal pieces of technology there. We take to Fortune 50 customers and say, we love them. We want to run our data through them. And they'd show us their data, and we'd hold our head in our hands and say, all right, that is going to be 6 or 12 months of ProServe just to get the data into a state where it wouldn't break the pipelines and create unreliable structured data in those knowledge graphs that we were building. And we went to...
So Brian, stop right here for our listeners who are not deep into the weeds. So I think a lot of listeners might have this false impression that here's a bunch of PDFs or here's a bunch of text, and not everything should be good to go.
Totally. Let's take an example of, say, like an equity research report, something like Ford Motor Company that like JP Morgan might put out. And it has a title, it has some body text, but it may have a text box over here talking about GM, and it might have a section down below talking about the last 12 months. Then it might have a market commentary, box on the top of the second page. What you really care about is that just that string of body text that kind of goes through all these text boxes in the middle, that's just talking about the last 90 days, right, for that equity in particular. If you're wanting to generate a summary on it or extract key information and index it in some sort of structured or relational database, the trick is like everyone has different formats, right? And maybe it's PDF, maybe it's a Word document, maybe it's HTML. And then also the document layout changes all the time. And so for data scientists, they're doing all this data engineering of, okay, how do I actually go and extract the data that I want to do the data science on? And that becomes a huge time suck, right? And it's the economics of it, both in terms of time and cost, are really, really difficult if you extrapolate this across large organizations that are producing hundreds of thousands of files a day that contain natural language data, and you want to exploit that somehow, right? And create new knowledge from it and make it more accessible. And so that's the problem that hit us head on when I was at Primer, and a lot of our peers in that space at the time, like Kendi and Kensho and others, I'm like, you know what? Like this is an area ripe for a company just to focus on in order to unlock a lot of those great NLP solutions that are to the right of it.
So, a bit of clarification. So, are we talking about information extraction? So, in the example you gave, right? So, of an equity report. So, an equity report will have a bunch of these boxes,
Yeah.
call out box. It may even have tables
Yeah.
and charts. So, there's one aspect where, okay, I'll extract information out of those so that I can run queries. But then some of our listeners who are not deep into the details of this, they're starting to use some of these new tools, Brian, like Llama Index, right?
Yeah.
So, where there might be a PDF connector from
Sure.
written by Unstructured, for
Yeah.
example, right? So for them, they go, I just use one of these connectors, I can start querying these PDFs. So what's the big deal here, Brian?
Sure. I think we kind of think about it as 3 steps that are needed to get to like crystal clean data in the abstract that you want to get to, and not every use case requires this level of precision. But let's kind of unpack this a bit. First step, transform the data. So if it's a PDF or Word document or PowerPoint or whatever, typically you want to get into like a JSON or a Markdown format. So that's one, is do the transformation. The second is there's probably going to be artifacts, that white spaces, Unicode characters, weird breaks, etc., that you want to clean up. So step 2 is clean it up. Just get to a baseline format that's clean. Step 3 is where we're really focused also, is on curation. And so if you want to create high quality structured data or improve the performance of the chat your data system that you're building with an LLM, one area that you can focus on to do that is just being thoughtful about what data you put in front of that model. And so imagine the performance of that LLM in summarizing that equity research report if you took out all that noise and you just isolated just the data that was most important. Without getting we're happy to go more technical on this, but what you end up with is smaller and higher quality embeddings in your vector database. And so when you're using something like retrieval augmented generation or one of the cousins of it, to allow an LLM to go retrieve data that's not in memory, you're able to do that nearest neighbor search and find high quality data, highly relevant data much more easily. And so you're asking a lot less of that model. That has implications in a few different areas. One, you may be able to run a lot smaller model. That's going to be a lot cheaper and faster from a latency standpoint. And then 2, you maybe don't need to do nearly as exotic of all this prompt engineering in order to get what you need out of it on the back end. And so there's a number of different areas that you can invest time and energy in order to enhance the performance of these emerging architectures. One of them that hasn't received a lot of attention because it's hard, it's unsexy, number of reasons, is on the pre-processing. And that is where we're laser focused at Unstructured.
And I think part of the situation we find ourselves in, Brian, is on the one hand, you have these APIs and this initial set of tools, right? So LangChain, Llama Index, and so on and so forth, and the LLM APIs. So people can easily hack together, prototypes, or even, extract information from these documents. But then what you're describing is that next step, when I actually want to do something much more precise or much more repeatable, much more production quality, right? And I actually advise another company in computer vision, which is doing something similar, but for visual data sets, where they're laser focused on data quality, deduplication, mislabeled data, blurry images,
Yep.
and so on and so forth. And obviously, you can do everything in text without doing any of these things. But as you point out, it might not be as good. It might not be as efficient, right?
Yeah, and I think the world that we think is that we're making a bet on at Unstructured that's coming very soon is one in which almost every job function in an organization is going to be accelerated and enhanced through LLMs. And in order to do that, you're going to need to bring to bear all the natural language data your organization, the private data your organization is producing, to an LLM. So how do you make that available in a way that's scalable? And so there's a few different aspects on it there. One of them is just the quality of the pre-processing. Another one is just from like the reason that we say ETL for LLMs is because this is something that's going to need to run continuously and feed into storage. Right now it's vector storage. Who knows down the road? But we see a world where emails and memos and reports and Slack messages and all of this incredibly valuable data is utilized in conjunction with these models in some way, shape, or form. And so how are you going to do that at scale, at quality, but also in a manner where the total cost of ownership of these architectures is not going to outweigh the economic benefit that they're yielding, right? Which is a huge challenge right now, given the compute requirements of running just the LLM, let alone the rest of the architectures. And so for us, we're imagining, how does an organization like Walmart or JP Morgan or Disney start providing LLM, enabled capabilities to HR and sales and finance and others on their private internal data so that they can do their work far more efficiently than they can do today, but also in a way that's cost effective.
And I think most people get the are aware of that classic line, garbage in, garbage out, right? So the better your data up front, obviously it affects everything downstream. And so while right now we're so enamored and focused on what we're doing upstream with the models, I think as we get serious, we'll realize that actually we should probably pay attention to that early part of the pipeline, right?
The last 5 or 10%, right, are the hardest. And I think, a metaphor here is what we've seen with smart agents over the last several months. Incredible demos. In practice, a lot of people are going to have to work for a long time to try and get these things working reliably enough that they can be used in production. And the same goes for production machine learning. It's still the case that like 80 to 90% of machine learning initiatives within enterprises fail, right? I think that this incredible developments on the model side, right, are going to decrease that failure rate. However, that's not enough in and of itself, right? If you're going to feed garbage data into it, right, or extremely noisy data into it, say you want to automate Salesforce updates, right? Like we have a family friend of ours works for a large insurance company. All she's doing all day is just taking emails and updating Salesforce. Here in the Valley, some folks would say, all right, well, that's automatable today, right? But is it automatable at a level of precision and reliability that you're willing to hand that off to a machine learning model? Achieving that F1 score or that level of performance, that's actually still very, very hard, and it requires a focus on that whole architecture, including the data.
So what are the components of a solution that you're describing? So I imagine OCR, or optical character recognition, is that an element of this? Because some of these PDFs do have information buried in images, right?
So exactly. And so our architecture tries to achieve two things. One, maximum performance for the lowest cost. And so that means that we don't push every single file type through the same pipeline. And so right now we have about a half dozen we call them strategies that users can capitalize on. But we also have an auto one where it automatically routes it to the most efficient strategy. And so if it's an image containing text, okay, we automatically go to a vision-based approach. However, if we're able to get access to that text, like it's a text file, we're not going to turn it into an image and use an image. And a more expensive model, we can actually parse it incredibly well using NLP models, or just old-fashioned regexes. And so on the image side, we have a couple different approaches that we're using here. One of them is a computer vision model to do document layout detection coupled with OCR. Works really well, or pretty well, pretty compute intensive. Another approach that we're spending a lot of time on that we'll have more to talk about later on this month is we've done a ton of work on taking like Donut and other vision transformer based architectures that are OCR-less approaches to this to try and achieve similar outputs. And we're having a lot of promise there. But again, we're working hard on getting inference time down so that they're more compute efficient. And so currently we support about 25 different file extensions, file types, and hundreds of different document layouts. We're going to want to make this even simpler and more performant over time. But the goal is that you can take an S3 bucket of 10,000 files, of anything, send it to our API. It'll get routed to the most appropriate strategy to optimize cost and performance, and then you'll get a JSON in a common structure across all that data on the back end, and so that reduce the amount of time and energy that these data scientists have to spend on data engineering.
So I apologize because I forgot to mention up front that Unstructured, at least right now, is open source.
Completely open source. Yeah. So our Python libraries, our images, and our API are all open. And
actually, after we talked, I realized I actually use Unstructured as my web connector on Llama Index.
That's great. That's great. Yeah, Jerry.
Yeah. And how often do you guys update that connector, by the way?
Once a week, maybe even more frequently.
And you know why I realized, because I was looking at some old code and I realized I switched to this other web connector because the other one kept breaking.
Is that right?
And then I actually remember my thought process, because Llama Index has this thing called Llama Hub, right?
Yep.
It's got several of these web connectors. Okay, so I'm not gonna make this mistake again. I'm gonna pick something where I think there's at least a company behind it.
Yeah. I think that Jerry Lew at Llama Index and Harrison at LangChain have done an amazing job of making it easy to go grab data with the data loaders that they have. We've seen some space there to do almost like what Fivetran's done for structured data on more enterprise.
That was my question, is that as you were building this company, right? So obviously a few years ago there was kind of a resurgence in interest in data engineering. And there were a bunch of companies that came up. Some of them are in the ETL, ELT data integration space, and then one of the bigger ones is Fivetran, right? So who were any of those companies conscious inspirations for you?
Yeah, I mean, Tristan at DBT and the whole team at Fivetran, and also Airbyte, but the Fivetran and DBT kind of combination,
Fivetran has the most revenue.
Yeah. but I mean, in terms of the value that they deliver, we really look up to them. The metaphor breaks down at a certain point, but from moving data and then transforming data and delivering that at a production grade, where enterprise customers can rely on you, that's really kind of our North Star that we're aiming for in this adjacent data category. And so hopefully we'll have a fraction of the success that they've had.
So take us through again. So I have raw PDFs or text sources, right?
Sure.
So you folks do your thing.
Yeah.
Right. So whatever it is that you do, your secret sauce. It's not secret, it's open source, I guess. And then if the end result, Brian, you mentioned JSON, but ultimately do people end up going to embeddings?
Yeah. So like tokenization, vectorization is really kind of like where we do a baton pass to either.
So where do you end? JSON or the embeddings themselves?
So the way that we've architected our pipelines, if you have an embeddings model that you want to integrate into our pipeline, that's really easy to do. Or if you want to take the JSON that you get and then send it to an embeddings endpoint, like an OpenAI endpoint, and then embed it that way, you can do that as well. And so we are not developing embeddings models ourselves. Like, we're leaving that to Cohere and OpenAI and Hugging Face for that. However, it's really easy for us to kind of tuck that into our pipelines if that's needed. And so what most folks do with like a chunked JSON that's ready to go from our end is send it straight into a vector DB and then create and vectorize it, and then have that vectorized representation joined with the JSON in a vector database. And so that's usually like the two places that they go afterwards, and then everything ends up in the vector database.
So do you have official connectors with some of the popular vector DBs?
Yeah. So we're working on Mongo's new Atlas right now, but we have actually the gang at Weaviate did an awesome piece on integration there. We've done work with Pinecone and Chroma and all the major vector DBs we integrate with pretty easily.
Now, I think I don't know if I've told you this, but my thesis, of course, is embeddings are important. I'm not clear if the vector database is a startup, is a standalone company or standalone system, because you can already see, Mongo adding it, Rockset adding it, Databricks adding it, Elastic adding it, right? So, but that for you folks, it doesn't matter, right? So you just send it to wherever I store it, right?
We're not doing any storage on our end. We just want to make it to get wherever it's stored currently, and we're going to be expanding our upstream connectors to like Azure Blob and SharePoint and etc., and then make it easy to send downstream as well. But we're not going to be doing any storage on our end, at least right now.
So how do you folks address scale? And please tell me you use Ray.
Yeah. A few different thoughts around this right now.
So is scale an issue that you've heard from people that you must address? Not yet.
Not yet. No. We're anticipating it. Some of the experience that we've had over the last several years at other companies, we've seen NLP solutions at scale, and some of the difficulties.
Or just ETL, you probably will need a distributed framework at some point if people have volumes, right?
So as far as we've gotten right now on this is that it's kind of two things I'll say. One, we've had a lot of success so far building through design partners and enterprise design partners, and we're going to continue doing that. And that's been unbelievably helpful in making sure that the way that we're building this is scalable. The second is we're not going to invent anything on our own here. And I think that Databricks' approach, where they have a control plane and a data plane, and trying to have as much of this occur within the customer managed environment as possible, is an approach that we're going to have to go to as well, because this data is among the most sensitive data that organizations produce as natural language data. And so in terms of like Ray or the distributed framework, different distributed frameworks are exactly how we scale here. We're focused on simpler stuff right now, like how do we get almost all the models working on CPUs that we can just horizontally scale, and off of GPUs, and those are challenging tasks in and of themselves. So that's kind of where we're at today.
So the other aspect, I guess I'll go through the old big data, volume, variety, velocity. So what about streaming in real time? Are those things at some point, ETL, data integration solutions will have to address those kinds of aspects too, right? So
yeah, I mean, right now, like, we're able to process fastest a few milliseconds. It's the slowest 5 seconds per document, which isn't great.
by the way, to your defense, this space that we're talking about, LLMs, they don't really have any handle on real-time data at all, right? So the vector databases are inherently batch oriented. There's not, they don't have incremental updates and real-time kind of capabilities. So, but you anticipate at some point, just like people have dashboards that they want to have somewhat updated, you want to be able to go to an LLM, chat with it, and be confident that it's somewhat updated, right?
Yeah, and I think, I mean, some of the architectures that our team has built out previously have had latency of only like 15 seconds, maybe 30 seconds from streaming data that's come in. It's just a question of like, how much are you willing to pay for that? And we haven't seen on the customer side that those requirements are there yet. But coming back to what we were talking about before, like that world is coming, right? And so we need to anticipate that and build towards it.
So in the classic data engineering pipeline, ETL, ELT kind of space, one
Yeah.
of the bragging points is connectors.
Yeah.
Right. So what are some of the essential connectors for ETL for LLMs in your mind?
So for us, we have a list of about 30 or 40 that we've crowdsourced from. That's the wonderful thing about being open source, is that we just crowdsourced from folks on the ones that are most important for them and from our customers that we have already. And there's nothing surprising here. The thing that is a little different than what might be on Llama Hub or the data loaders that the LangChain folks have is that a lot of them are really boring. They're not like a lot of fun ones. They're the ones that you've mentioned: Postgres, Elastic, Azure Blob, SharePoint, Google Drive. Some people have been asking for Notion. Google Cloud. We have, I would say, about 36. The goal is by the end of this month to have around 15 of those production grade connectors available in open source for everybody that we're maintaining on a regular basis, and then to expand that to probably 30 to 40. After that, it gets to be a pretty long tail of very, it's not very, there aren't a huge number of users for those beyond that. And so that's probably about 95% of the use cases are in that 30 to 40, at least right now, but that may change. But again, like the goal for us is like those are able to handle interruptions, able to handle versioning, able to handle scaling, and our team are maintaining those, and so that if something breaks on the schema, then we're updating them.
This is one of the I guess differences between Fivetran and Airbyte, right? So when Airbyte came onto the scene, and I actually talked to one of the founders. One of their things is we're open source, so therefore we have a lot more connectors because the community is building it. But then it turns out that Fivetran has all of the essential connectors and they maintain it, so the quality of the connectors is high. And by the way, if a integration becomes important, they add it.
Yeah.
So I think I'm more concerned about as I alluded to earlier in the Llama Hub example I had, I want a high quality connector that I know is maintained.
Yeah.
Right?
Yeah. I don't think data scientists who are our primary like target persona right now, and that may change, but even they don't want to maintain any of the stuff, right? They don't want to do a lot of this connectors or pre-processing, and I don't blame them. And so like our goal is to just make this effortless for them so they can focus on all the things to the right of kind of the workflow that we're focused on.
So how come your target persona is data scientists only and not ML engineers or data engineers or?
So right now, we just don't see a lot of data engineers working on natural language data. Our goal, if we're successful, is that we'll be able to get this off the backs of data scientists and into the hands of data engineers, and then eventually into experts who can help as well, where there's a lot of those like customer success folks as well, who can help set up data profiles when they're onboarding these as well.
I think you guys should start kind of elevating your profile in that data engineering space, because I think they will start coming online. And honestly, even developers will start needing the tools that you're building. And you want to be able to talk their language, understand kind of their concerns. Speaking of which, so what about data security and things like that in the open source project? So by the way, so in your mind, what's going to be kind of some of the key differentiations between what eventually will be the enterprise offering and
Yeah.
the open source project?
So the open source project is primarily focused on file transformation capabilities. And one of the reasons that we ended up open sourcing from the get-go was so that we can get feedback, but then also a lot of the customers that are extremely security conscious can deploy this into their own environments and run it without having to send us any data, right? And so, so that's been a focus from day one. Where this will start diverging, or they'll start being feature gaps over time, is around like what's needed to go beyond just the file transformation capability into something that's running in serial full time. And so, simple things like user management and resource provisioning, like SOC 2 compliance, having a control plane and a data plane, having a UI, a lot of this functionality.
Yeah, or orchestration.
Exactly right. Exactly right. We're going to build around that.
So there will be some kind of dashboard, right?
Yeah. And so something kind of along the lines of like what Data IQ and others have done. We think they've done some great work in this area on the UI's front. But the goal here is that right now it's an unbelievable moment kind of in tech history around like what's going on with LLMs. We want to support everyone that's prototyping with LLMs and like remove any barriers to getting their data, LLM ready, right? And so everything's open source right now. However, we recognize that open source project isn't going to be enough to move into production at a large enterprise, right? So we're going to build a platform, and hopefully as these prototypes move into production over the next 6, 12, 18 months, we can grow with them, right? And continue to meet their needs from a pre-processing standpoint.
So then does that mean, Brian, you start thinking about some of the things that data engineers over the last few years have had to deal with ETL and data integration for structured data? And by this, I mean, they're starting to increasingly inject software engineering rigor in how they build pipelines, right? So they're starting to do unit testing, integration testing, those kinds of things. So a lot more data quality checks, a lot more things around reproducibility. So, I mean, basically building some more rigor into how they build pipelines. So are you folks also starting to think about adding some of these kind of capabilities?
This is a huge area, I think, where there's an opportunity here on our end. We want the path to achieving that's a bit different than when you're dealing with columns and rows exclusively, right? But it's still the concepts hold no matter what. On our end right now, it's like, how can we get everything down to what we're calling kind of core document elements and have confidence that you've boiled everything down to these document elements accurately.
Yeah, how do you test, for example?
Yeah. And so on our side, we're building gold standard labeled data sets, right, to run it against internally to look at like performance. Like this is all like a new area, so we're setting up entirely new tests, generating our own gold standard labeled data sets for the testing, and we're just like that's over the last like call it 8 weeks. We've just begun setting these things up, and so we're looking at it in kind of like two areas right now, and it's going to get a lot more complex over the next year. One is just around the quality of the transformation itself, and so looking at the original and then looking at that JSON representation and ensuring that like recall and precision are at human level performance. The second thing that we're looking at is how well is this improving the overall architectures, LLM enabled architectures, and so we're getting pretty creative here on how we're setting these tests up, but around like, okay, if you're feeding this into a vector database and you're using something like LangChain and you have an LLM and you're giving it, and you're prompting the LLM, what's the quality of the return of that prompt of the inference with unstructured versus without unstructured, right? And then let's work back. I mean, that's what matters at the end of the day here. and using that as a smoke test for things that we might be doing wrong or could be doing better on our end as well.
So, just like other aspects of this LLM space, it's going to come down to a combination of automatic evaluation and some human evaluation.
Yeah. So we have lots of data labelers that are now being data evaluators for it.
So, just to give our listeners the flavor for the space of ETL and pre-processing data for LLMs. I imagine this is one of a lot of things in tech. It's easy to scratch an itch and build your own time series database or vector database over a weekend, post it on Hacker News, land on the front page, and but then, it's not really a polished or finished project, right? So give us a sense for what are some of the key traps and key challenges, and why. In other words, what I'm getting at, Brian, is let's try to get the listeners to just go use Unstructured, the open source project Unstructured, rather than kind of don't build this at home. Don't try this at home, in other words.
Sure. I would say if you're using off the shelf, like just getting practical here, if you're using just a PDF loader, works, it's really easy to get going with it. Hopefully we're about as easy to get going, but it's sending the embedding model just a wall of text, right? You're giving a wall of text of a certain size, and then it's creating a vectorized representation of that. And that may work fine for a few prompts on a cool demo and get a mind-blown emoji. However, if you're wanting to create really high quality inferences off the back end of that at scale on a variety of different,
and all the edge cases for these documents, right?
Yeah, I think a much more thoughtful approach to creating those embeddings and creating high quality embeddings, and this notion of data curation, which is I'm not just sending all the data in there. I'm actually just sending the data that is most meaningful into the vector database, right? And creating. And so I think that's the lesson that we've learned between, like, call it 2017 and 2022 on making BERT-based models sing. And I don't think that we're out of that world. It's just that these models are more tolerant of noise. But if you want to achieve human level performance or hopefully surpass it, this is a key area that you're going to have to make an investment is on data quality. And this is like the Snorkel folks and others have been talking about data-centric AI for a while. And I don't think that goes away. I think we've had this incredible moment where you can do some really cool stuff with these LLMs. But now the trick is, how do we start handing tasks over to LLMs, right? Full time. And it's in there that's the rub. And that's kind of what we talked about earlier. And you can do LLM fine tuning. You can work on your retrieval methods. You can take a different approach to creating embeddings and vector storage, and then you can also invest in pre-processing. And this is like a cheap area that will improve the performance of the overall architecture that you're deploying.
Or you can shop around for different LLMs.
Yep.
Right? So, but I mean, I don't think LLMs will overcome data quality.
No, I think, and there's we're seeing these massive context windows, which is really cool, and lots of high performant open source models, but you got to think about total cost of ownership of these things, as well as like the hardware requirements in order to make this work for even small teams. And so if you're going to have 10 or 15 or 30 concurrent users hammering an LLM, this architecture over time, like, you got to think hard on whether or not you're going to use a 30 billion parameter model or a 7 billion or a 1 billion parameter model, because that has big implications for the hardware stack that you need to spin up behind it.
So let's say I'm giving, I have you give a talk, which I am, but it's a panel. But let's say it's an actual talk, and I give you 2 to 3 slides of the coolest applications of unstructured that to date. Preferably not done by Unstructured itself. What would you highlight in your talk?
On our end, we've been doing some really fun stuff with our government partners on sensitive data where they've taken military PowerPoints and reports and others and automatically generated like situation reports, like morning briefings on like what's going on in a particular conflict zone. That's just magic to me, where they're just dumping in emails and PowerPoints and everything, and it's just like the model is able to spit this out, and we're a key enabling factor there. So that's one of them. Other ones are really boring, but they're just like it's like magic, and how much it improves the lives of a lot of our users. So there's been a number of different use cases where we've taken thousands and thousands of pages of like manuals or rules or regulations and just turn that into a chat your data about very, very quickly, either through scraping a website or ingesting PDFs and Word documents. And so you don't have to go and look through like a glossary or, the appendix.
So let's stay with these examples here. So if I just take the data that they have and don't use unstructured, just go directly at the data, what's the difference before and after unstructured?
Well, on the generative side versus I think the first example I had was like a generative example. The second one was an information retrieval.
Information retrieval, yeah.
On the information retrieval side, what you're going to be doing is feeding in a lot more irrelevant data back into that context window and asking more of the model. And so the hallucination issue on the answer is going to be more acute. And then also you may be missing out on other kind of, far astray relevant pieces of information that you weren't able to jam into that context window because the embeddings were so large.
I see. Right. So in closing, I'm assuming you're hiring?
Yeah, we're hiring, we're growing.
For question number one, are you fully remote or not? And secondly, what sort of folks are you looking to hire?
Fully remote, clustered in Northern California and DC right now, but open to other geographies as well. Hiring a lot of engineers, as well as beginning to build the sales team and marketing functions and other go-to-market functions as well. And so really kind of growing across the board.
Yeah, and with that, thank you, Brian. And like I said, if you want to meet Brian in person, come to the AI conference, September 26 and 27. More details at aiconference.com.
Thanks for having me.